Hello students, today we are going to learn about electron configuration and position in periodic table. Electrons are placed in the orbitals in the order of increasing energy. Electrons are first filled in the energy level 1, 2, 3, etc. and the same for the subshell S, P, D and F. With the exception of 3D is after 4S, 4D is after 5S, 4F is after 6S and 5D is after 4F. Orbitals are filled singly first, then paired. For example, carbon has a total of 6 electrons. To fill 1s with 2 electrons and 2s with 2 electrons and 2p with 2 electrons. Chemists use electronic configuration to show the placement of electrons in an atom. The lower energy sublevel is written first and then the higher energies. The number of electrons in each sublevel is written as a superscript. As here you can see, the first main shell, 2 electrons are filled in the first main shell. Second main shell, 2 electrons are filled in the S subshell of the second main shell. Again, the second main shell with p orbital. 3 electrons in the p subshell of the second main shell. The abbreviated electron configuration uses noble gas configurations, which have full electron shells to describe the electronic structure of later elements. As you can see the example of helium here. As you can see the example of the electronic configuration for helium, which is 1s2, and carbon, it is 1s2, 2s2 and 2p2. You can write the abbreviated electronic configuration of carbon as helium 2s2, 2p2. If you want to write the complete and abbreviated electronic configurations for silicon, step 1 is to state the number of electrons from the atomic number on the periodic table. For example, silicon has an atomic number of 14, which means it has 14 electrons. Step 2, write the number of electrons for each orbital in order of increasing energy until filling is complete. Electronic configuration for silicon, it is 1s2, 2s2, 2p6, 3s2, 3p2. Step 3, write an abbreviated electronic configuration by replacing the configuration of the preceding noble gas with its symbol. That is, abbreviated electronic configuration for silicon can be written as neon 3s2, 3p2. Here we can see some examples of element, its orbital diagram, its electronic configuration and abbreviated electronic configuration. First one, lithium, electronic configuration is 1s2, 2s1. 1s2 is the electronic configuration of the noble gas helium. Hence, we can write the abbreviated electronic configuration as helium 2s1. Now here we can see the first example, sodium. Sodium is with electronic configuration 1s2, 2s2, 2p6, 3s1. 1s2, 2s2 and 2p6 is the electronic configuration of neon. Hence we can write the abbreviated electronic configuration as neon 3s1. Now let's try to answer some questions. Which of the following subshells has the highest energy? It is 3p. Next question. In what principal energy level is 3d subshell located? It is 3. What is the electron capacity of 4p subshell? P subshell, it can accommodate 6 electrons. What is the electronic configuration of nitrogen with 7 electrons? It is 1s2, 2s2, 2p3. What is the abbreviated electronic configuration of silicon? It is neon 3s2, 3p2. The properties of elements can be correlated with the electronic configuration because the number of electrons equals the number of protons. The periodic table tells us about atomic number and electronic configuration. The horizontal periods in the periodic table shows increasing principal energy level. The vertical groups indicates the sublevels S, P, D, and F. The S blocks includes hydrogen, helium, elements in group 1 and group 2. Elements in the S block have the final 1 or 2 electrons in an S orbital. That means all the elements in group 1 and their electronic configuration with S1. And all the elements in group 2 and their electronic configuration with S2. The P block consists of elements in group 13 through group 18. There are 6 P block elements in each period because the 3 P orbitals can hold up to 6 electrons, including the noble gases. All the elements in group 13, for example, end their electronic configuration with P1. The D block contains the transition elements. The D sublevels are 1 less than the period number. There are 10 elements in each block because the 5 D orbitals can hold up to 10 electrons. F block contains the inner transition elements, the 2 rows at the bottom of the periodic table. The F sublevel is 2 less than the period number. There are 14 elements in each F block because the 7 F orbitals can hold up to 14 electrons. How you can use the sublevel blocks on the periodic table to write the electronic configuration for chlorine. Locate the element on the periodic table. Chlorine with atomic number 17 is in group 7A or 17 and period 3. Step 2 is to write the filled sublevels in order going across each period. The first energy level, 1s2. Second energy level, it is 1s2, 2p6. Third one, 3s2. And the last step is to complete the configuration by counting the electrons in the last occupied sublevel block. It is 3p5. The electronic configuration for chlorine can be written as 1s2, 2s2, 2p6, 3s2, 3p5. Now let's try to answer these questions. Use the periodic table to determine the element with each of the following electronic configuration. The electronic configuration given here, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. The sublevels have been filled in order going across each period. There are 7 electrons in the 3d sublevel and the 7th element is cobalt. So the element here, it is cobalt. In the second example, we have an abbreviated electronic configuration, which is argon 4s2, 3d10, 4p5. First is the electronic configuration of the noble gas. Then the sublevels have been filled in order going across each period. There are 5 electrons in 4p sublevel, and the fifth element in the 4p block is bromine. So the element here is bromine. Thank you for attending this session. See you in the next one.